Hello, everybody. Today is Friday. I want to go over two problems like the ones I posted for Friday. We got a special guest here. Say hello, everyone, Frederick. Hey! Who is that? Do you see who that is? Yeah. Oh, say hello, everyone. Do your work. He says, do your work, everybody. So, I decided to do this video with my wonderful son, Frederick, here to help me. He's going to be a great math whiz one day, I hope. Yeah. All right, so the problems I posted on Friday are kind of, they're the most interesting ones so far. You use the same processes, but in sort of a novel way, a new way, a really interesting way, I think, in my opinion. So I want to go over just two problems, maybe help you out with those a little bit. The first one is x to the 8th minus 36x squared. And of course, the first thing we always do, is GCF. So, is there a greatest common factor I can pull out? Yeah, absolutely. He's right. We can, because there's an x in both of these. Remember, you always factor out the lowest power, so we're going to factor out an x squared. And I'm left with x to the 6th minus 36. Now, I'm going to use the difference of squares formula here. It's incredibly important. Oh, you want to check that out? Yeah? Does that look right? You checking my math? So the problem, I mean, 36 is a perfect square, so this sort of is intuition. You should be able to kind of figure out, yes, this is something I think I could do because 36 is a perfect square. But x to the 6th is not. However, if I can rewrite x to the 6th as something squared, it works. So if I can rewrite this as something squared, I'm going to be able to use my formula. I know I can rewrite 36 as 6 squared, right? But how do I rewrite x to the 6th as something squared? In order to do that, you need to remember your properties of exponents. For instance, if I had x to the 7th raised to the 3, that would be equal to x to the 21. Because anytime you have a power raised to a power, you multiply them together. So I need to put x to the 3rd here because 3 times 2 is 6. That means I've got something squared minus something squared. And those somethings are my a and b, which means I can rewrite this as x cubed plus 6 times x cubed minus 6. And that's my answer. Now, the one on your worksheet's a little bit different, but you use the same concept to be able to figure it out. All right. You want to play with the computer? Too bad. Okay, let me go over one other problem that doesn't use these. Because one of the problems I put, it was an interesting problem, because I think it is actually kind of an interesting problem. Are you looking at Mandy? And it's because you don't have an x squared and an x and a constant. You have an x to the 4th, an x to the 2nd, and then a constant. Let me write the problem up here. X to the 4th plus x squared minus 20. Now this is a different problem than what I gave you, obviously. But here's the thing. Anytime you have a problem in this form, and this power is twice as much as this power, 4 is twice as much as 2. If I had a 10 here and a 5 here, if I had a 20 here and a 10 here, anytime this power is twice as much as this power, you can use the AC method. No problem. It works the exact same way. So if we were going to use the AC method in this case, I would look for the factors of a times c, which is negative 20, and look for the ones that add together to positive 1. So I'm going to have negative 1, positive 20, negative 2, positive 10. You right? Okay. And then -4, +5, and those are the ones I'm looking for. So I'm going to split up my middle term into 4x squared and 5x squared. So I've got x to the 4th minus 4x squared plus 5x squared minus 20. So I've split my middle term according to my magical numbers, and I group them. I know it looks a little bit different, but the process is still the same. And then from here, I'm going to factor out the greatest common factor of x squared, and I'm left with x squared minus 4 plus, from here, the GCF is going to be 5, x squared minus 4, x squared minus 4 in both of these terms, so I can factor it out. And I'm left with x squared plus 5. Now that works. So anytime this power is twice as much as that power, you can do this process. Now, I'm not actually done. I'm not going to finish the problem, but this is not fully factored because x squared minus 4 can be factored even further using the difference of squares formula. And you're going to have to do that on number 3. All right, that's it. Say goodbye, everybody. Goodbye. Happy quarantine. Happy social isolation. Hopefully he made you smile a little bit. He makes me smile a lot. All right. Y'all have a really great weekend, too. See ya.